everyone. My name is Bhanita Das. I'm working as an assistant professor in the Department of School of Pharmaceutical Sciences, University of Science and Technology, Meghalaya. So today I'm going to give a presentation on a very important topic from B.Pharm second semester, Pharmaceutical Organic Chemistry 1 subject, that is Markovnikov's rule and anti-Markovnikov's rule. So these two are name reactions that are very important for B.Pharm second semester student, and I hope my presentation will help you all. So let's start the presentation. First, we will discuss about Markovnikov's rule. So when we are saying Markovnikov's rule, according to him, he said that when an acidic reagent is added to an unsymmetrical alkene, the positive part of the reagent will attack to the double bonded carbon which has the greatest number of hydrogen, and the negative part of the hydrogen will added to the double bonded carbon which has the least number of hydrogen. So according to Markovnikov rule, he said that when we are reacting an acidic reagent with an alkene, at that time what happened, the positive part of the reagent will go and combine with the double bonded carbon which has highest number of hydrogen, and the negative part will go and combine to the double bonded carbon which has lowest number of hydrogen. So now let's check one example and let's check its mechanism for better understanding. So for the acidic reagent, I have taken hydrogen bromide. So when we ionize our hydrogen bromide, it will definitely give a positive part and a negative part, right? So the Markovnikov's rule mechanism is consist of 3 steps. So in the first step, what we did, first we take our hydrogen bromide and we ionize it to give a proton and a bromide ion. Definitely the positive part will be the proton only and the negative part will be our bromide ion. So in the second step, what we did, the proton attacked the double bonded alkene to form carbocation, right? So what happened, first we ionizes our hydrogen bromide. So now if we take our hydrogen bromide to react with an alkene, then what happened, there are 2 possibilities that the hydrogen can react, right? So the first possibility I have mentioned it here as an A, and the second possibility I have mentioned it here as an B. So according to the first possibility, the hydrogen can go and combine to the double bonded carbon which has highest number of hydrogen, and it give rise of a carbocation, that is secondary carbocation. And when in the second possibility is that the hydrogen can go and combine with the double bonded carbon which has least number of hydrogen, so it can go and combine with the second carbon, and we got a carbocation, but now it is a primary carbocation. So from this attack of the proton to the alkene, we got 2 product, right? That is both are carbocation only, but one is secondary and one is primary carbocation. And now we have to apply our Markovnikov's rule, because according to Markovnikov's rule, he said that the positive part will go and attack to the carbon, double bonded carbon which have highest number of hydrogen, right? So if we are noticing in this step 2, the hydrogen, if it attack the double bonded carbon which has highest number of hydrogen, then the possible product it form is the secondary carbocation. So we can clearly say that for Markovnikov's rule, the secondary carbocation will be go for further step 3, right? So in the step 3, we take the secondary carbocation, and when the secondary carbocation is attacked by the leftover bromide ion, then it form the major product. Why it is major product? Because from the secondary carbocation we got our product. Why? because in the secondary carbocation only the hydrogen go and combine with the carbon, double bonded carbon, which has the highest number of hydrogen. So we apply Markovnikov's rule and we found that we got a product, and that is we considered as major product because there are two possibility in step 2. So if we consider this is as a major product, then the other will be considered as minor product according to Markovnikov's rule. So Markovnikov's rule is not that much a different topic. It is a very easy and understandable topic, and I think it's very important for BPharm second semester student. The concept, it's very easy. In Markovnikov's rule, what we did, we take an acidic reagent which will react to an alkene, and then what happened, we divide the acidic reagent into positive and negative part. So the positive part will definitely go and combine with the double bonded carbon which has what, highest number of hydrogen, and the negative part will go and combine with the carbon which has least number of hydrogen. So, and then when we apply the mechanism, we finally found our product, the main product, that is the major product, and the leftover product is it will be named as minor product. But since we are talking about only Markovnikov's rule, so we will only show the major product. So I hope you all will understand. This is nothing much, but there is only 3-step mechanism. In the first step, we ionizes our acidic reagent, and we all know that when we ionize the hydrogen bromide, the hydrogen will be the positive part and the bromide will be the negative part. And in the second step, what we did, we take the positive part of the reagent, right, that is our H plus ion, that is proton. So when this proton react to the alkene, there are two possibility the proton can react. The first possibility I have taken it as a A, and the second possibility I have denoted it as a B. So if we are going for the first possibility, we got the secondary carbocation, and if we are going for the second possibility, then we got the primary carbocation. For the first possibility, we got the secondary carbocation. So from that, we choose the secondary carbocation. Why? Because in the secondary carbocation only, the positive part of the reagent attack to the double bonded carbon which has highest number of hydrogen, and that is why at in the last step we choose the secondary carbocation to yield our major product. So this is very simple, Markovnikov's rule. And now I'm going to discuss about anti-Markovnikov's rule. So I have taken this both topic together because these topics are same with each other, but they have a little bit difference in the sense whatever happening in Markovnikov's rule, the opposite thing is happening in anti-Markovnikov's rule. That's why they put the word anti. Anti means opposite, right? Yes. So so if I ask you all that in Markovnikov's rule what happened, you have to say that the positive part of the acidic reagent will attack to the double bonded carbon which has highest number of hydrogen, right? So in anti-Markovnikov's rule what happened, the positive part of the reagent will go and attack to the double bonded carbon which has least hydrogen, and the negative part will go and attack to the double bonded carbon which has highest number of hydrogen. That is, the opposite thing is happening. So according to anti-Markovnikov's rule, when an acidic reagent added to an unsymmetrical alkene, the positive part of the reagent attack to the double bonded carbon which have the least number of hydrogen, and the negative part of the reagent is added to the double bonded carbon atom which have the greatest number of hydrogen. I hope you all getting my point. The difference between Markovnikov's and anti-Markovnikov's, it just happened for the reagent, right? Nothing is changes in the alkene, just changes are in the reagent. In the Markovnikov's rule, the positive part attack the double bonded carbon which has highest number of hydrogen, and in the anti-Markovnikov's rule, the positive part will go and attack to the double bonded carbon which has least number of hydrogen. So that is the minor changes happening, others everything is same. So similarly, like Markovnikov's rule, in anti-Markovnikov's rule also it will contain three-step mechanism. So in the first step, again we have to take our acidic reagent, right? So our acidic reagent is hydrogen bromide. So if we again ionize the hydrogen bromide, it will give a H plus ion and Br minus ion, right? Yes. So now we ionizes our hydrogen bromide. And then in the second step also it is also same like our Markovnikov's rule. We have to take the alkene and then we have to take the positive part of the acidic reagent, that is our proton. So when this proton react to the double bond, then what happen, again there is two possibilities. Similarly like Markovnikov's rule, here also two possibilities. The first possibility is that the hydrogen can go and combine with the carbon which has highest number of hydrogen, and the second possibility is that the hydrogen can go and combine with the carbon which has least number of hydrogen. And again we got two carbocation, right? First one is secondary and the next one is primary carbocation. So now we have to apply our anti-Markovnikov's rule. So if we apply our anti-Markovnikov's rule, then now we have to choose the primary carbocation, right? Why we choose the primary carbocation? Because in the primary carbocation only the positive part will go and combine with the carbon having the least number of hydrogen. If it is Markovnikov's rule, then we have to again choose the secondary carbocation. But since it is not Markovnikov's rule, it is anti-Markovnikov's rule, so now we have to choose the primary product. So if we choose the primary product, then what happen, the primary product will take, then the leftover bromide ion again we have to react it with it, and then we got our product. And this time this is will consider as major product, because now we are talking about anti-Markovnikov's rule. So similarly like Markovnikov's rule, in anti-Markovnikov's rule also we will get major and minor product. So the major product now is this and the minor product will be the secondary carbocation. So I think mechanism is also same, right? In Markovnikov's also there are three steps, and in anti-Markovnikov's also there are three steps. The difference is between in the last step, right? Because in Markovnikov's also until the first and second step everything is same. We have to take our acidic reagent and then it will go and attack to the alkene, right? And there are two possibility in the step 2. In a Markovnikov's also there are two possibility, but everything changes in step 3. So we have to take our bromide ion what is left over, and then we have to take our alkene, right? Or not the alkene, sorry, we have to take our carbocation, and this time we have to choose the primary carbocation instead of the secondary carbocation. And when we choose our primary carbocation, then ultimately we got our product, that is our major product. So both this reaction is a very important topic for B.Pharm second semester student. So if you notice that almost everything is same, the main thing is happening with the reagent, right? So whatever reagent is attacking in Markovnikov's rule, the opposite reaction is happening in anti-Markovnikov's rule. That's why it is put as anti-Markovnikov, that is the opposite thing is happening. So this mechanism is very simple. There is nothing hard here. The same thing is happening again in both the name reaction. And yes, this is a very important topic for all the B.Pharm second semester student. So I will again in briefly I'll say it, that in Markovnikov's rule, the positive part of the acidic reagent will go and combine with the double bonded carbon which has highest number of hydrogen, and the negative part of the reagent will go and combine with the double bonded carbon which has least number of hydrogen. That is our Markovnikov's rule. And if we go to anti-Markovnikov's rule, then the positive part of the reagent will attack to the double bonded carbon which has least number of hydrogen, and the negative part of the acidic reagent will go and combine with the double bonded carbon which has highest number of hydrogen. So that is only the changes happening in Markovnikov's and anti-Markovnikov's rule, and other things are almost same. So yes, first step is same, And yes, steps are also same. In Markovnikov's also it is 3-step mechanism. In anti-Markovnikov's also it is 3-step mechanism, right? So the first step is also same. In Markovnikov's also, in the first step we take the acidic reagent and then we ionize it, and when we ionize it, it form a positive part and the negative part. That is, a positive part is considered as the H plus and negative part is considered as bromide minus ion, that is bromide ion, right? Yes. So now then in the second step what happened, we take the example of the same alkene. Then what happened, first we have to react it with the hydrogen, that is our proton, the positive part of the acidic reagent. And when it attack there are two possibility, right? In Markovnikov's also there are two possibility. So till here it is everything is same, but in the step 2, after the step 2 we have to apply our rules. So when we apply Markovnikov's rule, we choose the secondary carbocation, right? Because in the secondary carbocation only the positive part go and attack to the double bonded carbon of an alkene which has the highest number of hydrogen, right? So in Markovnikov's rule we choose the secondary carbocation. But in anti-Markovnikov's rule what we did, we choose the primary carbocation. Why? Because in the primary carbocation only the positive part of the acidic reagent go and combine with the double bonded carbon which has least number of hydrogen, and when we apply that we choose the primary carbocation. And then we take the primary carbocation, we react it with the leftover bromide ion, and we got the major product. Here also this is the major product, and the other possibility that will be considered as minor product. So if your teacher asked you that if it will give they will give you a reaction and they will tell you identify the major and minor product, so you have to identify it like this. Okay, so for Markovnikov's rule you have to choose the secondary carbocation, and for anti-Markovnikov's rule you have to choose the primary carbocation. And then similarly the main product will be considered as major product and the leftover product will be considered as minor product. So I hope this PPT will help you a lot. And yes, these two name reactions are very important for B.Pharm second semester in organic chemistry. There are lots of name reactions, and these two are also very important. And yes, the steps are almost same. Three steps. First two steps are similar, only the changes in the step 3. So yes, this is also very simple one. And with this I want to end my presentation, and I want to thank you all.